there's a great deal of variance in the way that we each assess the activity of our recombinant proteins. Manufacturers will use a variety of methods. And I think what happens at the end of the day is that you're less able to kind of move from one manufacturer to another and achieve consistent results. And that's a problem because, again, if we're thinking about the integrity and resilience of our supply chains, it's very difficult to onboard secondary suppliers and to be able to toggle between different sources of these critical materials if you really have to adjust your entire process once you onboard them. So for us, it's critical that we ensure the consistency and reproducibility of the way that we assay these products, because this will ultimately have an impact on the integrity of the cell therapies that come out downstream from us. So what do we do and how does it differ? So what we know is fairly common in the cell therapy industry on the production of cytokines is that biological activity is typically measured by an ED50 comparison. You basically take the entire concentration response graph, which you can see on the right, and you really measure and connect directly to the specific activity of the protein. But it creates a little bit of variability from one measurement to the next because you're not first assessing the statistical validity of the samples and of your process. On the other side is really the parallel line assay approach, which is what we employ at Akron, which is what the WHO has used, the World Health Organization has used when talking about the standardization of biological activity assays for IL-2 in particular. But we really start with the parallel region of the graph. We ensure that we are passing tests for statistical validity before we actually measure the relative activity of our sample to the standard, and then generate values. And what that allows us to do is generate consistent results from lot to lot. So as a cell therapy manufacturer, you're typically building your process off of a reported activity value on a certificate of analysis that's provided by your cytokine provider. Now, at the end of the day, if there's variability in the way that that assay is run and the results that are reported, regardless of how consistent the product might be behind it, you're going to have to adjust your dilutions and your manufacturing process downstream, and you're going to have a much more difficult time comparing across suppliers. So as I mentioned, the way we approach this challenge is by going to the basics, understanding what is accepted by leading authorities and by standardization bodies in the industry. So we start with our parallel line approach because we understand that it generates a statistically valid result, and that any variability that we'll see beyond that is likely owed to biological variability. The fact that we're working with biologics and there is going to be inherent variability from one lot to another, but we're able to tighten that margin of error and ensure that what we're generating at the end of the day is a sample with, is a product at the end of the day with less variability from lot to lot. So we align our principles of design behind these assays and our principles of analysis beyond these assays in line with the relevant USP chapters around the design of biological assays and around the analysis of these biological assays. So we think that this is incredibly important for generating a robust and consistent product. And ultimately, we think that this is critical for us to standardize among cytokine providers, because this is going to determine how the entire industry is able to grow the availability of suppliers without having to do costly rework to ensure that we're able to work across different suppliers in our supply base. So we think that the standardization is critical. And what you see at the end of the day, and we'll just show briefly, is that our biological activity remains fairly constant across lots. So there's a kind of a selection of a couple of lots here. And what you find is that we're typically around the value of the standard, and that we see relatively little variability. Now, this is owed both to the process that we employ to manufacture our cytokines, in this case our IL-2, but also due to our measurement methods, which I think are incredibly robust and allow for consistency across lots. So I think that this is an important point to drive home.